This video is about Mifare Ultralight EV1 128 bytes. And in this video, I'm going to show you how to program and how to work with this type of tags using the ACR122U reader writer. This is identical to Mifare Ultralight EV1, which has a 48 bytes. The only difference here is this has the extra memory. This has got 128 bytes of user memory, so you can put more data in these type of tags. The Mifare Ultralight EV1 tags are very popular in the transport industry. I've seen one of these type of tags used in Italy. It is in Venice. So this has got a dynamic locking, which is identical to NTAG 212 NFC tags. If you have already worked with NTAG 212 tags, then you know that the dynamic locking here is identical. Now, the reason this has a dynamic locking is because it has the additional user memory. With the older version of EV1, which has got only 48 bytes of user memory, the static locking is enough to lock this 48 bytes. Whereas to lock the additional user memory, so there has to be a dynamic locking, extra locking bits, which are called the dynamic locking. I've already made so many videos on Mifare Ultralight EV1 and NTAG 212, and I have covered every detail in those videos. I would suggest you see those videos. So it was difficult for me to procure these tags from internet in just few in numbers. So I'm going to provide you a link where you can buy these type of tags with less than 10 numbers. So I'll be demonstrating using ACR122U, and I'll be using a brand new tag. Now this is the memory structure of Mifare Ultralight EV1 128 bytes. Sometimes if you search internet, this is also called MF0UL21. Now you can see here, from the developer's point of view, you just have to understand this memory, the structure in the tag. So the top bit, so this structure is more or less the same. So if you compare this with the Mifare Ultralight EV1 48 bytes, it has identical structure. The only difference here is this bit, the user memory bit. So we have got more user memory. Now this also has got the counters. Now this is the structure of NTAG 212. So it looks identical with the NTAG Mifare Ultralight EV1, the 128 bytes one. So more or less, they are the same, but it does have some additional features, this NTAG 212. Otherwise, both the tags have got 40 pages of memory. The only difference here is the Ultralight EV1 has got the counters, whereas NTAG 212 doesn't have the counter. And also there is a small change in the configuration, CFG0 and CFG1. Now this is the dynamic locking structure of Ultralight EV1 128 bytes. So again, keep in mind, because this tag has got more user memory, there has to be additional locking bits. So the NXP calls these locking bits as dynamic locking. Now here, the dynamic locking bytes or the bits are stored in page 36. The first 3 bytes are used, as you can see here. So the byte 0 the byte 1 and byte 2 are used and byte 3 is not used. If you look at this byte 0, every bit, the bit number 7, so they lock 2 pages at a time. If you compare this with the static locking, where every locking bit locks a single page, whereas here a single bit locks 2 pages. If you can see here, if this bit is set to 1, this is going to lock the page number 30 and 31. If this bit is locked, or if it's set to 1, you are going to lock the page number 26 and 27. So likewise, you can lock all the extra user memory that is provided in the stack. And this is also called the block locking, the BL lock. And I don't want to waste my time and your time explaining what is the block locking. I would suggest you to see my Mifare Ultralight EV1 videos and NTAG 212 videos. So put in simple words, so block locking, so this prevents locking any of these bits. So if the block locking 32 to 35, if this is set to 1, I'm going to demonstrate these things on my the later part of my video. But if you want to know the theory behind that, the best advice is read this Mifare Ultralight EV1 document. It's available on internet. Now if you set this bit, to 1, so it's going to block the locking bits from 32 to 35. So 32 to 35, it's somewhere here. You cannot set this to 1 and this to 1. You cannot change the locking bits of these two. That's what the BL means. It's called block the locking. So all videos related to ACR122U is available in this playlist. It's called Learn to Use ACR122U Reader Write Effectively. If you click here, so I've got more than 42 videos. Plus, there are videos in a different category, but they all use ACR122U. So I would suggest you to read the videos on the Mifare Ultralight EV1. These are the first 4 videos. I covered everything in detail. And if you want to know that NTAG 212, probably that will be in a different playlist. If I go back, so I got around 200 videos in this channel. Please, if you want to know more about this, please go through all these videos. They're very useful. It has got a lot of information in there. And this is the document which is common to both 48 bytes and 128 bytes Mifare Ultralight EV1, and you can get this from my internet. And it's a very, I'm sure if you have seen my videos and if you like playing with these type of tags, you will certainly love reading this document. In fact, I explain how to understand this document in my videos on Mifare Ultralight EV1. You can watch them as well. So in all my video series, I was using this software called ACR122U Made Easy. So this is a software you get if you are in the training center. But if you don't have this software, you don't have to worry, because you're going to learn a lot of stuff from this video. So you can understand, get some knowledge, and you can play with this tag with whatever software you got. Now what I'm going to do is, I'm going to show you this video of my reader just for the next couple of minutes. Then I'm going to take it out so I can just focus on the main screen. You can see I've got ACR122U reader writer, and the version of the software is 2.9. and if you go to the menu and if you see the release notes, and if you see that the last changes to the software was done almost 2 years ago, probably because of the COVID and things, nothing has gone into the software. And the very first introduction of Mifare Ultralight EV1 was done almost like 3 years ago. If you look at that, it's 3 years ago. So if you already have this software, you will get this updates automatically. Now I bought around 10 Mifare Ultralight 128 bytes tags, and I've already played with one. This is the brand new tag. I'm going to place it on my reader writer and just select the tag. You have to choose Mifare Ultralight EV1. Now once you do that, it just is a normal process. You activate, and the software says it has detected the 128 bytes Ultralight EV1. And from here, I'm going to continue. I'm just going to focus the main screen just on this window. So then, okay, you don't have to see all these backgrounds. Okay, now once you activate and the software has detected it's 128 bytes. If you're a programmer, you have to go and see these commands. Again, all these commands are identical to the 48 bytes Ultralight EV1. In fact, there's literally no change to the software in the way the commands are used. The only difference the changes my developers have made is to show you more information in the grid, and also to show you the dynamic locking. Again, as I mentioned before, this is identical to NTAG 212, so things like this are very easy for the developer. They just have to copy paste the functionality from 212 into this screen. So yeah, you have to keep seeing, just watch this Mifare Ultralight EV1. Now, how did the software detected it's a Mifare Ultralight EV1? It's all to do with the get version. If you look at the commands, the last command was get version, and we get this information. The difference here is the 0E. For the 48 bytes it was 0B, and for this it is a 0E. Again, it's very well explained in the document. Now go to here. So the software decode this as 128 bytes. There's no change. Most of the thing, I would say 95% of the things I do here is a repetition from my videos in Mifare Ultralight EV1. So get ECC, the VCSL command was moved from locks to here because I need extra space for this dynamic locking. Now read that, little no difference. Now once you do this thing, you just have to say read tag. Now the software, if you want to know what's happening or what type of commands that are used in ACER122U, this is the best place to say. Now you can see again all these are explained in my video in Mifare Ultralight EV1. So you can see here there are more user memory. So the user memory starts from page 04 and goes up to page 35. Again, whatever I'm saying now, it's a repetition from NTAG 212. It's exactly the same. So if you've already seen NTAG 212, then probably you can stop seeing anything beyond this point, because it's the same stuff. So this has got, just go through that. Just you can see it has got that first 2 pages is where you find the UID, and the page number 2 is where you find the static locks, which is over here. The static locks, it has got a bits that controls the page. So for every page there is a lock bit. Again, that the first the top part, up to the user area, up to probably the page 15, is identical to the older version of Ultralight. That's the Mifare Ultralight, which has got no versioning or a password, which is just a straightforward, just like open tag. So you know now what's the static clock bits. The OTP, one time programmable, which is very much used in the transport system. So here, now here, this is a 32-bit values. So every bit, you can change. So I'm going to just show how the things are here. So assume that I'm going to change, use the first bit. So click here and say write. It's in writes, and you can see that the value got updated on the screen. Now this is just a simple memory write operation. There is no special command for OTP. You can see here, it's just a memory write. So you can write here if you want to change any data. So you should go here. There's a small change here. Before it was called user data, the tab here. Now it's called OTP and the counter. So I thought this makes more sense than just a user data, because the purpose of using Mifare Ultralight EV1 is because it has a counter. It has got 3 counters. Again, you have to read the documentation. These counters, they cannot be locked. They're always active and they're always up counter. These are 22 bits up counter, and you got 3 counters. So you can play with the counter. So I can go and increment the counter by say 5. Type 5 here and say write, and you can see here, so the counter 2 is increased by 5. And there are special commands again. So there is a command called read counter. So since, and as I mentioned before, the last video was done 2 years ago, I have to go through the documentation to understand what it is all about. Now the A0122U doesn't have a command to increment this Mifare EV1. You have to use a command that is specific to PN532 processor. A0122U, if you open that and see, there is a processor called PN532. I remember I made a video dissecting A0122U box and showing you it has a PN532 RFID reader right away in XP. So now you know how to use this counter. You cannot reduce the count. You just have to keep on incrementing the counter. So the main thing here is to understand about the 128 bytes is the dynamic locking. So you got more memory, more user memory. So if you want to put some stuff, more data, so you can see here all these things have changed now. You can go up to 35 bytes. Probably I'll go and grab quickly some lorem ipsum characters, and I can show you how to do this bulk writing. So this is some lorem ipsum characters. Okay, now again, so there is a restrictions here. You cannot put more than 128 bytes. So you can do that. You want to transfer this from this part of the screen to the grid. So put the save. You got everything over here. You can see in the ASCII mode. Now you can write everything from here to here. So before that, I'm going to clear these commands. So go here and say write. So everything got written. So what I'm going to do is just going to take this tag out. Probably I can close the screen, take the tag out. Probably can hear the sound in the background and activate, read the tag. You can see that you got all the data back. See this Mifare Ultralight EV1, this version 128 bytes. Again, the configuration pages are identical to the Mifare Ultralight EV1, the 48 bytes one. So I would leave that to you. I would suggest you to see those videos. Probably the only thing I have to show here is this has got more memory, and everything is identical to my the video I made on Ultraligh EV1. So the only difference here is the dynamic locking. So this locking again is identical to NTAC 212, but I'm going to show you how to dynamic locking and show you how the locking works. So here, as I mentioned before, from the documentation, every locking bit, it controls 2 pages. So assume that I want to lock. So assume that you're done with writing the data, and I would like to lock the page number 34 and 35. So you just have to identify which bit is that. So this is over 34. So here, and say write, and you have to be careful here. So once you lock it, you cannot unlock. It's just like a one-way ticket. So S, and if you see, there is nothing special about the command. It's just a simple write command to this memory page, to the dynamic locking page. Okay, you can see the data is immediately refreshed on the screen. So from this point on, in fact, the documentation says as soon as the page is locked, the locking will be effective from that instant of time. So I've seen some tags where once you lock the page, you have to restart the reader. Okay, you have to again take out the card, okay, out of the reader. Basically, you're powering down and putting back on the reader. Whereas here, it's immediately effective. Now, what you can do is try to change this and see if you get an error. Now, I'm going to go to this this one. I can see the data of this page is visible here. I would like to make a change. So set that to 0. Say 0, and try to write. In fact, in the software itself, it's stopping you from writing. So the best thing to check that writing is not possible is, I'm sure you can use this the safe mode off. Turn the safe mode off. Yeah, you can take it out. Now when this is in off mode, it lets you do whatever you want, but keep in mind you just cannot write to a lock page. It's not possible. Like you cannot read from the password page, you cannot read from the pack page. It's not possible. If a page is locked using the static locking, you just cannot unlock it. A software cannot do that. So I'm not sure about any hardware can do it, but a software cannot unlock a lock page. I keep getting lots of questions in the channel whether you can read the password. It's just not possible at all. It's highly impossible. So here I'm going to change this to 0 0 and say write. Now it says surprisingly it says write page okay. It could be because sometimes this the write page command from AS122U it's not 100% right. Okay, so you have to be very careful with that. Okay, now let me go back. So keep in mind it's a page 34. So I'm going to deactivate and activate read, and if you go to page 34, you can see that it is not, we are not able to change the data to 0. So that means the write command from AS122U gave a wrong result. It said write was successful. So again, we just have to keep this in mind. So otherwise you have to change the technical team AS122U. But I would just keep this in mind, say that it's not possible to write. So let me try to write this again. So set this to 0, and so go to the safe mode, write. Yeah, somehow you always get this as success, not sure. Write it second time, you might get error. Yeah, look at that. So there's something wrong with the AS122U first time. It says first time write is successful, but second time when you write it says it's an error. So whenever you get an error in any of these operations, you have to reactivate the tag. So the software could have done that, but this is a learning software. You have to know when you send a wrong command, or when something like this writing to a lock page happens, you have to reactivate the tag, go through the collision and everything, activation process. I think the rest of the things are same. If you want to change the password, by default, the password is all FFF. You can authenticate. So you can change the password in the pack anytime, as long as they're not protected. If you come across a tag which has got auth 0 in the configuration 0 as a 555, it's not protected. You can go there right anytime. So likewise, you can also change the pack. You can change it anytime, but keep in mind you cannot read this password in the pack. I'm going to change this password as 1 as well. Say right. So I've changed the password. Now the next what you can do is now you know what the dynamic locking is all about. Okay, now I'm going to show you this block locking. Now assume that you do not want the user to make any changes for dynamic locking bits. Now take for example this BL 32 and 35. Now you have to find out what is the lock bits for 32 to 35. 32 is over here and 35 is over these two. Or take a different example, 28 and 31. So 28, 31. If you know these two log bits, I don't want anybody to make any. I want these two, these 4 pages from 28 to 31. I want them to be always unlocked state. So what I can do is I can go and say block locking. Write that. Now what the software has done is it has sent the command, write command, and from this point on you just cannot lock this thing. So this will always be unlocked pages. Again, what you do with this thing, and it's all up to you. It's all how you design the system using these type of tags. But this is a feature available in the system or in the tag. You can prevent any software, anybody from locking the pages. So that is done through this BL. So BL means blocking the lock bits. So the other thing, before I finish is sometimes when I get this VCL failed, not sure why. Okay, probably I have to reactivate. Read the tag. Yep, get ECC. Now I have again spoken in detail about how to use the configuration page 0 and 1. Just to give a little bit idea about that is, in config page 1 you can control how you want to protect the pages here. Now assume that I want to protect from page number 4. From page number 4 onwards I want to protect. I don't want anybody to write from page number 4 onwards without any password. So to do that, first what you do is you set this auth 0 here. So from page number 4 onwards I want to protect it. So that's it. Now you can see here, by default the protection mode is right. Now if you want to write to page number 4 onwards, you must first authenticate the password. So we're going to do that. Again, this is one of the important thing here called the authentication limit. Now how do you control when somebody tries to attack the card by using the brute force method, like putting the password in a loop and trying to do that. Now if it is 0, the card will not lock itself. It will let you send the wrong password infinite number of times. So you can limit that. Assume that I want the card to lock automatically after 3 unsuccessful password. You can set that right. So you can change that. Now if I take this out and try again, want to activate again, Now you can see if you try to write to page number 4, so I'm going to set this to 0 and write. It says, this is the software. This software is trying to protect it. It's trying to tell you that, write to protected page, authentication required. But I'm going to turn the safe mode off. Now, again, this could be a problem with the A722 write operation. Try to write again, you'll get error. Now, what you have to do is you have to first authenticate. So the password is all set to 1. Authenticate done. Now I can go and change. Probably I'm going to use a different method here. I'm going to change from page number 4 to say page number 30 and set this to number 0. Set 0. Okay, right operation, right. So I can see here up to page number 30 everything is set to 0. So how do we know the write is successful? Just go and read again. You can see that the data is still. You can see also the output of the read binary command. Okay, that's all about Mifare Ultralight EV1 128 bytes. I hope you understood the difference between the 48 bytes and 128 bytes. Some blocks, they refer to this tag as Mifare Ultralight EV2. So I hope you enjoyed watching this video. Thank you, and looking forward to seeing my next video.